Question number 37. It says 2-point charges A and B having charges plus q and minus q respectively are placed at certain distance apart and force acting between them is capital F. If 25% of charge of A is transferred to B, then the force between the charges becomes. Now you have to calculate the force between the charges when 25 of the charge is transferred from point A to point B, that is from charge A to charge B. So how do you do it? This is again from the chapter electrostatic. We have two charges, suppose plus q and minus q. They are kept at some distance. The distance is given in the question? No. So 25% of the charge is transferred to minus q. So your charge q plus q will become q, that is its original charge, minus 25% of its charge will get lost and will be gained by this one. Okay, q minus 25 by 100 q, that means q minus how much? 1 by 4 q, that is q by 4 I can write down. So plus q have this much amount of charge now, and minus q will have, it already has how much charge? Minus q, plus it will get an addition of how much? Q by 4. Q by 4 transferred to minus q. So this one will have minus 3q divided by capital 4. Now you have plus q and minus q. Both we have. Now we'll use the formula F is equals to K q1 into q2 divided by r square. Let us consider the r is the distance between them. So initially how much they will have before transfer? It will be, if this is also q and this is also q, the total charge, so it will be k q square by r square. This is initial charge, initial force. But after transferred, the force will change to, your q1 will become how much? This much, right? And q2 will become this much. So this one will also be 3q by 4. This one will be 3q by 4. So put q1 and q2 and you will see that your answer will come out to be 9f by 16 if you put in this formula, right? So see, 9f by 16, that is option number 2. Please try to see this answer by yourself by doing it and finding the formula. Now we'll move to the next question, that is question number 38. Question number 38, it says that a small hole of area of cross section 2 mm square is present near the bottom of a fully filled open tank of height twice h. You need to take g equals to 10 meter per second square. The rate of flow of water through the open hole would be nearly, you need to calculate the rate of flow of water. This is again from class 11 chapter, which one? Mechanical properties of fluids, and the topic is Bernoulli's theorem. Okay, the application of Bernoulli's theorem, that is Torricelli's theorem. You will see that is the speed of a flux. But before that we have to see equation of continuity also in this topic. We know equation of continuity, Q is given by AV. A is the what? Which is constant actually, AV. A is the area, V is the velocity, A is the cross sectional area which is given to you in the question. And according to Torricelli's theorem, when a water is coming out through any hole, this velocity remains V is equals to root over of 2gh. So in place of V I will write down 2gh. So A is given to you in the question 2 mm square, and G is given to you, that is acceleration due to gravity, that is 10 meter per second square, and H is also given to you, that is height is 2 meter. Now you just put the values, you will see that the answer is coming out to be 12.6 into 10 to the power minus 6. Now let us see which one is the correct answer from the option. If you see, number 1 is the correct answer. So that is all we have from this question. Let us now move to question number 39. Question number 39 is from the chapter semiconductor, where we have discussed about logic gates, but this logic gates has to be discussed again, because logic gates is a chapter which has been not given in NCERT nowadays. Okay, so in NCERT we do not have any topics from logic gates, or from CBSE the syllabus of logic gates has been reduced. So but then also I will explain you the meaning, but for that you just need to know how do you find this question if you have studied logic gates. If you see the question, a diagram is given. 6 volt, out here it's written like that, and a resistance is connected here R, and we have another resistance connected here, and then a bulb is connected. This is the bulb, and a switch is given here. This is considered as A, and then this is considered as B, connected here, and whole charge will come to the ground B. Now you need to find out the conditions where this bulb will glow. When this bulb will glow. Okay. Now see, in the form of logic, if I put truth table A, B and Y. So at first when I give A equals to 0, B equals to 0, when I say 0, 0, it means there is no current flowing, means it has low voltage. 0, 0 means it's an open circuit also. So whenever it will be 0, 0, the whole 6 volt will flow through this one. That means the current will flow through this and this bulb will glow. So your Y will be 1. 1 means high. It will glow. Whenever there will be 1, it will glow. Now I have a condition when it is 0 and 1. Again, this one is 0 and this one is 1. So this 6 volt will not flow through this one because this is already 0. It will be non-conducting side. So the whole current will flow this one and the current will glow, bulb will glow, right? Now I have another condition where A equals to 1 and B equals to 0, means this one is 1 now and this one is 0. So that means whenever this current will flow, this part will be conducting but this portion will not be conducting, right? So in a way it will not make a complete circuit. Again the 6 volt will flow, that means the current will flow through this one, you will get 1 here, right? Now next condition, when it is 1 1. So 1 1 will be what? This is also conducting, this is also conducting, the whole current will come like this and it will flow in this way, right? That means there is no passage in between. So this bulb will not glow in that time. So 1 1 will give you 0. 0 means it will not glow. So if you look at this one, it acts like which truth table? For 0 0 1, 0 1 1, 1 0 1, 1 1 0. This is for NAND gate. So your final answer number 39 will be, it will be NAND gate number 3. Number 3 is the correct answer. So now let us move to the next question, that is question number 40. In question number 40, it is asking, in which of the following process heat is neither absorbed nor released by the system? In the system, the heat will remain constant. Neither any outer heat can enter the system or any heat from inside can go out of the system. What type of process is this? Isothermal? No. In that one, temperature remain constant but there is a heat exchange. Adiabatic? Yes. As we know, adiabatic is the process where there is no heat exchange between the system and the surroundings takes place. So number B is the correct answer, and this is from the chapter thermodynamics. So number B or option 2, same thing. So option 2 is the correct answer, adiabatic. Now let us move to the next question, that is question number 41. Question number 41 says that a 800 ton coil of effective area 0.05 meters square is kept perpendicular to the magnetic field, perpendicular, remember the word perpendicular means theta equals to 90 degree, magnetic field 5 into 10 to the power minus 5 Tesla. When the plane of the coil is rotated by 90 degree around any of the coplanar axis is in 0.1 second, the EMF induced in the coil will be, how much will be the EMF induced when the coil will be rotated at an angle 90 degree in time 0.1 second. That is what we have to calculate. It's from the chapter electromagnetic induction. So we know the EMF induced is given by, that is E according to Faraday's law of electromagnetic induction, minus d phi by dt. It can also be written as minus delta phi by delta t. That is the change in flux. Now, how do you calculate the change in flux? That is delta phi. Flux formula is NBA cos of theta final minus NBA cos of theta initial. See, theta final is given to you. It's in the question it is saying that it is rotated till 90 degree and initially it will be 0 degree. Number of turns you know. Okay, area is also given in the question. Magnetic field is also given in the question. Time is also given in the question. So if you calculate delta phi, then EMF can be easily calculated. EMF will be equals to minus delta phi by delta t. So put the values and get the answer. Your answer will be 0.02 volt. You just have to solve this one. So finally, if I solve, the option will be number 4 is the correct answer. Now let us move to the next question, that is question number 42. Question number 42, it says that the radius of circle, the period of revolution, initial position and sense of revolution are indicated in the figure. You need to see the figure very carefully. In the figure it is saying that 3 meter is the radius. So I can say this is the radius, means this is the maximum displacement by the particle, that means amplitude will be 3 meter and its time of revolution is given to be 4 seconds. So how do you calculate? What you need to find out, you see, y projection of the radius vector of rotating particle P is, that is what you have to calculate. So it's in question from simple harmonic motion. You can write down y is equals to a cos omega t. In the option if I see, all are in cos. So a we already know, that is in the question given to be 3, and cos omega, what I can write down? Omega can be written as 2 pi by t. Now t is given to be 4 seconds, so 2 pi by 4. So 2 to get cancel, 2 and 4, which is coming out to be pi by 2. So in place of omega, I will write down pi by 2 multiplied with t. So this is your answer. Simply you can solve using the formula. If you see the question and the option, your final answer will be number 4. Yt is equals to 3 cos pi t by 2. T got multiplied inside. So number 4 is the correct answer. So I can give a right on it. Yeah. Now let us move to the next question, that is question number 43. Question number 43 says that a parallel plate capacitor of capacitance 20 microfarad. When I say the word capacitance, you already understood this is from the chapter what? Electrostatic potential, chapter 2 from class 12. A parallel plate capacitor of capacitance 20 microfarad is being charged by a voltage source whose potential is changing at the rate of 3 volt per second. There is a change of potential is 3 volt per second. The conduction current through the connecting wire and the displacement current through the plates of the capacitor would be how much? We need to calculate the conduction current as well as the displacement current. Now displacement current again within the capacitor which flows, okay. So displacement current is a bit concept from the chapter electromagnetic waves also. So that makes the question, but we'll use the concept of potential only and we'll find out. We know the charge in a capacitor is given by Q is equal to C multiplied with V. Now differentiating both sides, I can get dq by dt is equals to C being constant dV by dt, right? So dq by dt is your current I and C is given in the question, that is the constant, how much? 20 microfarad. So I can write down this one as 20 into 10 to the power minus 6. 1 microfarad is 10 to the power minus 6 farad, and dV by dt is given to you as 3 volt multiplied with 3. So your current will come out to be how much? 20 into 3 is 60 into 10 to the power minus 6. So how much? It will be 60 micro ampere. But remember one thing, out here the conduction current in capacitor is nothing but the displacement current only. Within that space only the current flows. So your conduction current also 60 microampere, your displacement current will also be 60 microampere, right? If you look at the question 43, option number 2 will be your correct answer. Now let us move to the next question, that is question number 44. Question number 44, it says that in an experiment, the percentage of error occurred in the measurement of physical quantities A, B, C and D are 1%, 2%, 3% and 4% respectively. Then the maximum percentage of the error in the measurement, where x is given to be a square b to the power half divided by c to the power 1 by 3 d cube, will be. This is from the topic error analysis, where the percentage error can be calculated. It is shown to you. Please see that topic, and if you see and do it nicely, this is a numerical which you have to solve by yourself. The concept is given in the formula in class 11, topic error analysis. So your answer will be option number 2, that is 16%. So I can click directly on 16%. So this is question number 44. Now let us move to the last question, that is question number 45. Question number 45 says that a cylindrical conductor of radius r is carrying a constant current. The plot of the magnitude of the magnetic field B with the distance d from the center of the conductor is correctly represented by the figure. This is from the chapter magnetic effects of current and can be understood from the formula B equals to mu naught I by twice pi r. B is inversely proportional to the distance. Okay, at first it increases and then it decreases. So what do you think, which graph will be? Option number 3. So 3 is the correct answer for this one, right? So this is what we have from NEET 2019. I hope all the questions are clear with you. Please see one by one nicely. Wherever I have given you the formula, please practice the formula and find the answer of them. The one which was required to find the answer I have shown you. See the concept, read NCERT topics which is there in our videos. Okay, all the videos are being uploaded. Okay, please give it a good revision, then this question paper would be very easy for you and you can solve it with the help of the formulas which was done in NCERT. Thank you.